So this is a sort of a reboot of a previous video that I did on this exam. I got a comment saying that there were gaps in the audio, so I thought, okay, let's have another go at this. I'm not all that great at editing. I don't really like listening to myself. I'm a mathematician. I'm not a video editor. And I'm using an editing software called Descript, which seems to overpromise and underdeliver. So if anyone knows any good alternatives to that, please let me know. So this is Level 2 2025, Apply Algebraic Methods in Solving Problems. If I've got a bit of a croaky voice, it's also because I've got COVID. I've been stuck at home for the last 4 days. So I'm going to be using the paper that's provided, the resource formula sheet, and the calculator, which most students in New Zealand use. So here's the reboot. Hopefully this isn't going to be like the Star Wars reboots, and that it's not going to suck. All right, first up, question 1. Simplify 5y times the square root of y to the power of 6 over 64. So, good start to the exam. The radical sign here, remember, the square root of x is the same as x to the power of a half. And when we take the square root of, say, x over y, that's going to be the square root of x over square root of y. So if we copy this down, this is going to be the same as the square root of y to the 6 over the square root of 64. Now you should know that the square root of 64 is, of course, 8. You should pretty much know that. So this one here, so y to the power of 6 to the power of half. So 6 times half is y to the power of 3. So when we come to simplify, this is going to be y to the 5y times y cubed over 8. And I'm going to put a 1 there so I can multiply the top of the bottom. So 5y times y cubed is going to be 5y to the power of 4 over 8. And I would just leave it like that. I wouldn't put 0.6 or anything crazy like that. I would just leave it in that form there. Moving along, next question. Rearrange the expression 2y equals the cube root of 7x minus 5 to make x the subject. So when we make x a subject, we're going to end up with x equals something. Okay, what do we need to do first? We need to get rid of this cube here with the radical. So the opposite of taking the cube root is cubing, and whatever we do to one side, we have to do the other side. So 2y cubed is going to be equal to 7x minus 5. Taking the cubing both sides, they're going to cancel. All right, so let's get rid of this first. So 2y cubed is going to be 8y to the power of 3. And it's going to be 7x minus 5, and we're almost there. Let's add 5 to both sides. So 8y cubed plus 5 equals 7x. And then divide both sides by 7. So x is going to be equal to 8y cubed plus 5 divided by 7. Shouldn't have much problem with that one. Next, we're asked to consider the graph of y equals 2x squared plus ax plus b, where a and b are constants. One of the points where the graph crosses the x-axis is at 1.50, and the point -1, -5 also lies on the graph. Find the values of a and b. So for this one here, when they give coordinates like this, think of it when x equals -1, y is going to equal -5. And when x equals 1.5, y is going to equal 0. And then put these into this quadratic equation form here and see where we go. 99 times out of 100, we get the right answer. So let's put the first one in. So it's always going to be in the form y equals ax squared plus bx plus c, but they change it around here. Excuse me. So let's put this in. So -5 is going to be equal to 2 times -1 squared plus a times -1 plus b. So let's simplify this a little bit. So -5 is going to equal to 2 times -1 squared. -1 squared is 1. So it's going to be 2 negative a plus b. So let's bring this 2 over and swap them around actually. So -a plus b is going to be equal to -7. And let's do the same for this 1.5 business. So 0 is going to be equal to 2 times 1.5 squared plus 1.5 a plus b. So 0 is going to be equal to 2, so 1.5 squared is 2.25. 2.25 times 2, 4.5. So 4.5 plus 1.5a plus b. And now if you think about it, we have a simultaneous equation where we have two equations and two unknowns, a and b, and we can solve them. Let's bring this 4.5 over. And so we've got -4.5 is going to be equal to 1.5a plus b. So -a plus b equals -7, and 1. So this put a 1 there actually. 1.5a plus 1b is going to be equal to -4.5. And at this point, I will just use a calculator. So let's go to the equations. So a is going to be x and b is going to be y. So simultaneous equation solver. There are two unknowns. -1, 1, -7, 1.5, 1, -4.5. And we put that in and we get the answer. So a is going to be 1, b is going to be -6. B is going to be equal to -6. And there's our answer. This next one caused a bit of consternation, I know, from people who sat the exam. So a rectangle is inscribed, meaning the corners are on the circle, with a radius r, as shown in the diagram. The length of the rectangle is twice its width. So we're going to say that this is the length from here to here, and this is the width. This bit here is the thing you really want to get out of that. Not so much that you should know what Pythagoras' theorem is. All right, let's have a look at what that means. That means that the length is twice the width. So this is going to be 2w. Don't call this L, W, and R. If you don't need to use a variable in algebra, get rid of it as quick as you can. The other thing we're going to say is that this from here to here is going to be 2r. All right, so once we've set r and w, everything else follows. They have to be in the exact same ratio. So if we can find one of these in terms of the other, then we can solve it. So the area here is going to be 2w times w. So it's going to be 2w squared, i.e. 2w times w. Okay, so with that there, I don't know why there's a little r there. The area is going to be that. Okay, let's use Pythagoras' theorem now to see what we can do. So the C here is going to be 2r. So 2r squared is going to be equal to this side here, which is w squared, plus 2w, this side here, squared. So let's get rid of the brackets and let's square everything. So 2 squared is 4 squared. Is going to be equal to w squared plus 4w squared. Okay, let's collect up those w's. 5w squared. And now we have something that is starting to look like something we can use, because we have one in terms of the other. Let's bring this 5 over, get rid of it from both sides. So w squared is going to be equal to 4r squared over 5. That's fantastic because we know that the area is twice that. Okay, w squared is that, but we know that the area must be twice this thing here. So 2 times that is going to be 2 times 4 is 8. So the area is therefore going to be equal to 8 squared over 5. So this is one of the first trick would be to not have the L, the W, and the R if you can possibly help it. Always do yourself a favor by making things as easy as possible and getting rid of things as early as possible. And that's how you solve that one. And just like that, we're up to E. So solve 2, so 5 to the power of 2x plus 1 minus 120, okay, there's a trap there, equals 5x plus 2. And then there's a hint, let n be equal to 5 to the power of x. Alright, there is a trap here with this 120. It is tempting to try to convert that to base 5. So 120 is 5 to the power of what? It's actually, it's going to be log of 120 over log of 5, I think. It's going to be something nasty. Just leave that 120 as it is. We can't go to the end straight away. We need to break this up. Break both of them up, actually. And when we do that, we're going to do ourselves a big favor. So 5 to the power of 2x plus 1, just realize that is the same as 5 to the power of 2x times 5 to the power of 1. And 5 to the power of 2x is going to be the same as 5 to the power of x squared. And that's going to be important because n is 5x. Okay, so we can rewrite this as being n squared times 5. 5 to the power of 1 is 5. So 5n squared. And I think you see where this is going. The minus 120 is just going to stay as it is. And let's do the same trick here that we did over here. So 5 to the power of x plus 2 is 5 to the power of x times 5 squared. And 5 to the power of x is 5 to the power of x, but notice that 5 to the power of x is n. So that's going to be n, and 5 squared is 25. So this one here is going to be 25n. Okay, so now let's combine all of these terms together again. Microsoft trying to be really helpful and useful, they just pain in the neck. So, where was we? So, 5n squared minus 120 is going to be equal to 25n. And now we have a kind of quadratic in disguise. Let's bring this 25 over. So 5n squared minus 25n minus 120 equals 0. And now we can solve this for n. What I probably suggest we do straight away is divide everything through by 5. So let's divide that by 5. And we're going to get n squared minus 5n minus 25 is 100, so this must be 24 equals 0. Can we factorize this? So we're looking for two things that multiply to give us negative 24 and add to give us negative 5. Well, that's going to be n minus 8, isn't it? Yeah, n minus 8, n plus 3. Minus 8 plus 3 is negative 5. Then multiply to give us negative 24. Yes. All right. So that tells us that n must be either 8 or negative 3. And one of those is going to have a problem. So we're told n is going to be equal to 5 to the power of x. Remember, we want to find what x is, not n. So if n is 5 to the power of x, if we had negative 3 here, there is no value of x that is possible that will give you that answer. There's nothing we can raise that to. So x is definitely, n is definitely not negative 3. On the other hand, is there a number that is true? And the answer is yeah, there very definitely is. It's not going to be a nice number, but it's going to be a real number. So how are we going to solve that? We're going to take let's just take the log of both sides. The common log, base 10, is going to be equal to x times the log of 5, and there's both base 10, the common logs. So x is going to be equal to log of 8 over log of 5. That's probably okay to leave it in that form. If you wanted to do an approximation, you'd need to go to the calculator. So log of 8 equals, divide that by log of 5. So 1.292. Three decimal places. And that's how that's done. Moving right along. Question 2. What is the value of k needed to write 9x squared minus 30x plus k as a perfect square? If it's a perfect square, it has a determinant equal to 0. meaning it's just going to touch the x-axis and nothing more. So what do we do from here? A is 9, B is minus 30, K is K, C is K. So the determinant is B squared minus 4AC, and we want that equal to 0. So minus 30 squared minus 4 times 9 times K equals 0, and solve for K. So 30 minus 30 squared is going to be 900. 30 times 30 is 900, and negatives cancel. Minus 4 times 9 is 36. K equals 0. So moving this 900 across, so minus 36k equals minus 900. K must be equal to minus 900. Sorry, my nose is blocked. Remember, I've got COVID. And K is going to be that, whatever that is, 900 divided by 36, 25. Remember, the negatives and negatives cancel, so it's going to be 25. Let's do a quick test to see if this actually works. So if it's a perfect square, when we draw this, 9x squared, if it's a perfect square, it's going to just go down and touch the x-axis and nothing else. So if we g-solve this and find the root, there's just going to be the root, that one root there, no other roots. Okay, we jump ahead a little bit. I've just taken the night off, my voice gave out to me. So let's crack on. We're told to simplify fully this polynomial over this polynomial. When you have polynomials like this and you're asked to simplify them, usually the best course of action is to factorize them and see if anything cancels. So let's factorize this top one and then the bottom one and see if that is the case. Pretty much guarantee that's going to be the case. So the top upstairs we have this. So there's obviously a common factor of x. They're all even numbers, but I don't think they have anything in common other than the 2 by the looks of it. So what have we got? We've got 3x squared now, plus 13x minus 10. Okay, so when we factorize that, oops, what are we going to get? So 3 times negative 10 is negative 30. Two numbers that multiply to give us negative 30 to give us positive 13 are plus 15 and negative 2. So 3, 15x, negative 2x, negative 10. Let's rub that out. So let's go down here. Actually, let's move this kind of down here. Let's ignore the 2x for now. So 3x squared plus 15x. Let's do that bit first. And then the negative 2x, negative 10. So the common factor here would be 3x. And this is going to be x plus 5. And can we do x plus 5 here as well? Yep. Negative 2. So this is going to be 2x brackets x plus 5, 3x negative 2. So that's the top factorized. Let's move this up a little bit. And let's do the denominator. We're on to the denominator. The denominator is 5x squared plus 23x minus 10. Okay, there's no common terms, so 5 times negative 10 is obviously negative 50. Two numbers that add to give us 23 would be plus 25 and negative 2, wouldn't it? So 5x squared plus 25x minus 2x minus 10. So 5x is common term here. X plus 5. And here x plus 5 negative 2. So we've got 5x minus 2 x plus 5. All right, so now let's combine those together. 2x x plus 5, cool, that's gonna go. 3x minus 2 over 5x minus 2 x plus 5. They're going to cancel. So we have 2x, 3x minus 2 over 5x minus 2. I would say that is as simple as it's going to get. I'm just going to pause and see if I can simplify it anymore. So I did stop and try to simplify it. You can decompose it, but it's not really going to simplify things much. So that would be my final answer. Okay, this next one, I did break my rule for this one, and I did solve this beforehand. There's two ways, at least two ways to solve this one. You could do it by quadratic equation. That is, take all of this, expand it out, and then use the minus b plus minus square root b squared minus 4ac all over 2a, and you will get the right answer. It will just take a lot longer. I may do a video, maybe a supplement that after this. Okay, this would be probably, those of you asking which are the merit questions and excellence questions, I'd say this would probably be merit, this question. There is a quicker way to do it. We're just going to play around with it a little bit and get the answer. We're going to need to take the square root at some stage because there's a square root here and there's a square. So something is going to need to be square rooted. The thing which actually complicates things is this 1 here. So if I do the supplementary with the quad, you'll see what I mean. But let's do it the quick and the relatively quick and easy way. So we start off with 10 3x minus 1 square equals 2. And I'm going to cross multiply. So I've got 10 equals 2 3x minus 1 squared. And when I first saw this, I thought, oh no, am I going to need to expand this out? And let's simplify things a bit more. Let's divide both sides by 2. So that cancels. And that becomes 5. So 5 equals 3x minus 1 squared. And that's good. Some stage we have to get this square root in, and we might as well do it now. So let's take the square root of both sides. So move down a bit. So the square root of 5, and that's good because that tells us that the number that's a here is going to be 5. The square root of 5 is going to be equal to 3x minus 1, and this is really good because there's a 1 in there as well. So let's add 1 to both sides. And I should actually say this is going to be plus minus 5. Let's add 1 to both sides. So 1 plus minus square root 5 equals 3x, and this is looking really good. And then we divide both sides by 3, and we're left with 1 plus minus square root of 5 over 3. So A is going to be, how did they give it to us? A is going to be 5, B is going to be 3. And again, there's more than one way to skin a cat with this one. The tricky thing there is not trying to turn this into A and B, but just going with it and see what comes out, and knowing that when we take the square root of a positive real number, it's going to be plus minus, because the negative square root of 5 times the negative square root of 5 equals 5 itself. That's how we do that one. Moving on, so this one would definitely be merit question, probably high merit. So we're told to solve the equation 2 log base 5 x plus 6 minus log 5x minus 2 equals 0. And here are the log equations that you're given. So a real rule of thumb when you have these log ones and you're asked to solve, i.e. you want to have x equals some number at the end of it, get rid of the logs first, deal with the logs first. So first thing I'm going to do, I'm going to exploit, which rule is it? This rule here, bring this 2 at the top. So log base 5 x plus 6 minus log, and that's going to be squared, log base 5 of x minus 2 equals 0. Now what am I going to exploit? I'm going to exploit this one here. So log base bx minus log b of y is going to be this over this x. So I can rewrite that as log base 5 x plus 6 over x minus 2 equals 0, and I'm going to bring this 2 over so I can exponentiate the whole thing. So log base 5 x plus 6 over x equals 2. So now I can get rid of this log, and what I do is I raise 5 to the powers to get rid of this base 5. If you think about it, which rule would that be? We're going to go from this form to this form now. So x plus 6 squared over x equals 5 to the power of 2, which is obviously 25. Now we've got rid of the logs, and now this is starting to look like something that we can solve. So what I'm going to do now, I'm going to cross multiply. I'm going to bring this x across. So x plus 6 square equals 25x. And I'm going to expand this bracket. So here it's this a plus b squared pattern. So it's going to be x squared plus 12x plus 36. Remember, it's going to be a squared plus 2ab plus b squared, and it's going to equal 25x. I'm going to bring this 25x across and maybe write a bit clearer. So x squared, so 12 minus 25 is going to be minus 13x plus 36 equals 0, and now we can solve that. So either we can factorize it, or we can just use the calculator. Let's factorize it, because it's pretty obvious what the answer is going to be. So 36 says to be 9 and 4, and that works there. So this is going to be x minus 9, x, minus 4 equals 0, which means x must be 9, 4, or both. So let's check. If x equals 9, are we going to have a positive log for both of them? Yeah, and we are. And as long as those are both positive numbers, in fact, they're both going to be correct. Both are feasible. We're not trying to take the log of a negative number, is what I'm trying to say. Okay, that's how you do that one. Right, on to the excellence part of the question. Again, for those of you asking which of the merit, which of the excellence, this would be the excellence part. So we're asked to find the values of k that satisfy the simultaneous equations. And then it says here, given there is only one solution to the equations, find the value of k. So next year, when you're doing calculus, that will be really important. The reason they will be important is because one must be a tangent of another. And in that case, you would get one, have y equals some function, and the other one you'd set y as the, solve it for y equals function, and then you would get these two functions here. Let's call this a and call this b. A minus b equals 0. You would find where that's true. And I did actually cheat before I did this, and I did it that way, and you can do it this way. I may do a supplementary answer on that just to show you that it is possible. It probably takes a little bit longer than just straight out substitution, which is what I'm going to do in this case. So I'm going to solve this for y. I'm going to bring this 2x over. So we've got y equals 2x plus 13. And then I'm going to substitute it into the other equation wherever you have a y. So x squared plus 2k of 2x plus 13 equals 6k. And then I'm going to expand that out. Now, k is a non-zero constant, which means that k can be in the coefficient for the x and in the c and the constant part. So if we bring this 6k across, expand out this bracket here, we can actually get a quadratic where the variable is x. So x squared plus, and let's expand out the bracket, 4k, and I'm going to have the 4k next to each other because they're both constants, and x is the variable, plus 13 times 2k is 26k equals 6k, and I'm going to take this 6k across, get it equal to 0, and then it's just going to be, we're just going to use a quadratic equation. So x squared plus 4k x, I'm leaving a little bit of a gap there so you can see that's the coefficient, that's the variable, and you take away the 6 plus 20k equals 0. So if k is a constant, 20 is a constant, two constants multiplied by each other equals another constant, so we're good. Okay, we have a quadratic here. Let's use the quadratic equation to solve it. So a is going to be 1, b is going to be 4k, and c is going to be 20k. And if there is only one solution, that means that the discriminant equals, the determinant, sorry, equals 0. So that tells us that b squared minus 4ac equals 0. So 4k squared minus 4 times a, which is 1, times 20k equals 0. I have one equation, one unknown. So 4k squared is 16k squared minus 80k equals 0. We want to solve for k. We can factor out a k. So it tells us that k equals 0 is a possible solution. Or does it? And the answer is no. K is a non-zero constant. So that is not a solution. So therefore, 16k minus 80 equals 0 is going to be what tells us our answer. And I'm going to add 80 to both sides. And k is going to be equal to 80 over 16, which is 5. K is 5. And maybe you could test it. I probably wouldn't. That's how you do that. That's the excellence part. And again, there's a couple of different ways you could use to solve this one. Good thing in algebra, there's more than one way to skin a cat. We're up to question 3 already. So this question is an achieve question only. So we're asked to solve this. So we want x equals some number, and we're going to use this one here. So log b, so b is going to be square root of x, and to the power of x, it's the power of 6, equals 8. Now, square root of x is x to the half, so x to the half times 6 equals 8, and remember, a times b. So this is going to be x to the power of 3 equals 8. And you could take the cube root of 8, but you should really know that. And this is going to be 2. It's not going to be plus or minus 2 because it's an odd number exponent, but x is going to be 2. And that's that. Next question. Next question is a sort of a tricky achieve question. Quadratic equation ax squared plus bx plus c equals 0 has solutions of 1 over 5 and negative 2 over 3. Find the values of the integers a, b, and c. Okay, integers here. So this is a little trap. There are at least 3 different ways of solving this one. I'll show you the easiest way. There is one in which we use a little trick. We find out x minus 1/5, get that equal to 0, and then solve that. Sorry, x equals 1/5, and then bring them all over and have it so that it will be equal to 0, and then solve it that way. There is another method called using Vieta's laws or rules. I'm not sure which ones they are. Vieta's formula, in which case R1 plus R2, those are the 2 roots, that equals negative b over a, and when we multiply the 2 roots together, we get c over a. We don't know what a is. It's not really going to help us much in this case. Let's just go with the easiest way. So if we know these are the 2 roots, we could rewrite this as x negative 1/5 and x plus 2/3 equals 0. And that's going to give us the numbers, and then we're going to multiply out to find the integers essentially. So when we multiply out these brackets, I'm going to cheat maybe a little bit. We get negative 1/5 x plus 2/3 x minus 2 over 15. I won't take you through the mechanics of adding and subtracting fractions. I'm presuming you know how to do that. So x squared plus 7 over 15 x minus 2 over 15 equals 0. They want it as integers. So what is a quadratic which would have the same solutions the same roots, but doesn't have these fractions. If we multiply the whole thing by 15, oops, so 0 minus 15 is 0, this equation here is going to have the same roots as this equation here. It's just that if we draw it, it's going to be, one of them is going to be really shallow, the other one is going to be like really huge, but they're both going to cross at the same points. And that's our most simple solution, that one there. The other methods I tried out, I get the same answer, so that is the correct answer. All right, so this is a achieve/merit question. A bit of slightly tricky, but it should be doable. If P equals log A3 and Q equals log A5, log A75 in terms of P and Q. So what are we going to do? We're going to exploit these formulae here. What we want is 3. We've got 3 and the 5. They both have the same base as 75. So we want some way of making 75 a multiple of 3 and 5. 3 times 5 is obviously 15, but if you think about it, 75, where's my pen gone? 75 is 3 times 5 squared. 3 times 25 is 75. So we can now exploit this one. We're going to have to do something with the x here, but that's fine because we can now exploit this rule here. So let's do that. So log A of 75 is going to be log A of 3 times 5 squared. So exploiting this rule here, this is going to be equal to log A of 3 plus log A of 5 squared, but we can put the 2 at the front here. Remember this rule here. So now we have log A 75 in this thing here, and lo and behold, that is P, that is Q, it's just multiplied by 2. So log A 75 is P plus 2Q. It looks a lot harder than it actually is. So as long as you stick to the formula here and have an understanding and intimacy with those, you can probably work your way through that. On to question D. So I know that this one caused a lot of consternation by people who sat the exam, and I strongly suspect this is the excellence question. As of doing this, the final marking scheme hasn't been released, but I'm pretty sure this will be the excellence question, not the last one. So I think they've done a bit of a switcheroo on you. So an expression for the sum of 2 squares can be written a squared plus b squared equals a plus b squared minus 2ab. If a and b are solutions to the equation, quadratic equation there, find an expression for a plus b in terms of m and n. So for this one here, you would need to use Vieta's formulae. There's more than one of them. So what do they say? They say that R1 plus R2, which are the two solutions, that's going to be equal to minus B over A. And R1, R2 equals C over A. And it's complicating things because they give A, B, C there. And here it's the other way around. So I'm going to rewrite these in the form that they want them. Okay. So A plus B is going to be equal to M over 1, because A is 1, and A times B is going to be equal to C, and C in this case is N. Fair enough? So, A plus B, hey presto, it's there. It's M squared. Minus 2AB, AB is N. So Vieta's formula already does it for you. There's no point reinventing the wheel here. So A squared plus B squared is going to be equal to M squared minus 2N, and we're done. So knowing Vieta's formula there helps you a lot in this. If there's any formula that you really should be looking at doing, it's that one there, and really knowing that quadratic equation, because this is derived from the quadratic equation, is really worth your time. So the next one is golf. So Shiloh, so obviously her parents listen to too much Neil Diamond, plays a golf hole. She starts the day, I'm sure you know how golf goes. Normally they start there, go to there, then across, but she wants to be daring, and she wants to go across the tree. So the start, the tee, this thing here, is 2 meters above ground level, i.e. the flag. The ball reaches maximum height of 20 meters when it is 110 meters from the start. Tree is 7.5 meters and is 200 meters away from the start. Assume that the flight of the ball can be modeled by a quadratic equation. So a lot of information there. The trick here is knowing the quadratic equation always makes a parabola, and a parabola is always symmetric. Where do we make our origin point? We're going to make our origin point actually here, where we hit the ball. Well, not where I hit the ball, where Shiloh hits the ball. And this thing here is not going to be the x-axis. I'm going to have the x-axis here. Notice here, at no point they tell us how far the final flag is, where the hole is. So we need to do a bit of redrawing here. So this isn't going to be 20 meters. This is going to be 18 meters. And this tree is not going to be 7.5 meters. It's going to be 5.5 meters. And it's going to be 200 meters away. And the height is still the same distance away. So it's going to be 110. So we do know 3 of the points here. We know we start at 0, 0, where she hits the ball for the first time. And we know that it goes through the point 1, 1, 0, 18. And we also know, because it's symmetric, it goes through the point 220, 0. Distance from here to here is the same as the distance from here to here. We don't really care about the flag. Once we find the equation for this path, we can work out whether 200, 5.5 is above or below that line. Okay, how do we do that? You can do that straight away on your calculator. In fact, I'll show you how to do it, but I think they want you to show how you do it with Algebra. But I'll show you how to do it. So menu, stat, and we're going to enter 0, 1, 1, 0, 2, 2, 0 here, and then we're going to go across 0, 0, 18, 0, and then we are going to graph 1, calculate the parabola, and it's going to be that. So that is going to be our parabola there. And then if we draw that again, same thing. But we're not going to do that. We're going to resist the temptation to do that. So how else might we do it? We know that the parabola, let's say, is always in the form ax squared plus b x plus c, that's going to be squared. We know that the c here is going to be 0 because the c is where it crosses the y-axis, and the y-axis crosses it there in the origin. What we can do then is we can put these the 2 points here, 110, 18 and 220, 0, into these equations here and get the answer for A and B. So just take a note of that. 110, 18 and 220, 0. So let's do the first one. 18 is going to be equal to A times 110 squared plus B times 110. Remember, x here is 110. So 18 is going to be equal to 110 squared. 110 squared is 12100. Right, now let's do this one. So 0 is going to be equal to A times 220 squared plus 220b. So 0 is going to be equal to whatever 220 squared is, 48400. Okay, now we can just go in the calculator to do simultaneous equations, which I probably suggest you do. Maybe say that you use the calculator to do that. So F1, number of unknowns. So what was it? 12100, 110, 18, and the other one is 48400, 220 and 0. So now we want to solve it. So A is going to be equal to 9 over 6050 minus 9 over 6050. B is going to be equal to 18 over 55. Okay. So our parabola is going to be y equals negative 9 over 6050 x squared plus 18 over 55 x plus 0. Now we've got the equation of that parabola. Now we want to check at 200, is that going to be more or less than 5.5? So y at 200 is going to equal minus 9 over 6050 times 200 squared plus 18 over 55 times 200. And we could do that on the calculator, but I'll show you the quick way of doing it using the calculator. Let's go to graph mode. Let's delete the last graph. So minus, back a bit, minus 9 over 6050 x squared plus 18 over 55 x. Put that in, draw it. There's our parabola. Just to prove it, and we want to go to gsolve, and we want y calculate when x equals 200 is 5.95. Okay, 5.95 is greater than 5.5 by 45 centimeters. So she does make the shot by 45 centimeters. How about that? And that's the end of the exam. I think that would probably be a merit question, not an excellence question. I suspect this is the excellence question here. And again, Vietta's formulae are really useful. So that's a kind of reboot of that exam. So apologies for the people who watched the last one and got a little bit frustrated that it was the sound quality and for some reason it didn't come out the way it was supposed to come out. But we've done it again.